In this video, we will discuss about minimum limit of balls in a bag. You are given an integer array nums where the ith bag contains nums of 5 balls. You are also given an integer max operations. You can perform the following operation at most max operation times. Take any bag of balls and divide it into two new bags with a positive number of balls. Your penalty is the maximum number of balls in a bag. You want to minimize your penalty after the operations. Return the minimum possible penalty after performing the operations. So what they are saying is that in the input, we are given an integer array nums and we are given another integer which is max operations. So now what we want to do is that we want to minimize our possible penalty. Now what is our possible penalty? So these nums is nothing but an array of bags containing some number of balls, right? So here there is one bag which is having the number of balls as 9, right? So out of all the bags, whatever is the maximum number of balls that is present in the bag, that maximum number you need to minimize, right? And that minimum possible value you need to return as your answer, right? So in this particular case, if you see, there is only one bag which is having the number of balls as 9. So right now your penalty is 9. This is the minimum possible penalty right now. Now you need to minimize it. Now how can you minimize it? So you are given another thing which is max operations. So you can perform these many operations on the array, right? Now in one operation, you can take any bag out of this and you can split that bag into two, right? And while splitting that bag into two, both the bags should contain positive number of balls, meaning this 9 cannot be distributed into two bags in one containing 0 number of balls and other 9. No, we can only distribute it to 1 or 8 or 2 or 7, meaning the bag should have positive number of balls. We cannot give a 0 balls to a particular bag, right? So now after applying these many operations on any bag, you want to return the minimum possible maximum number of balls present in all the bags at that moment, right? So now how are we going to solve this? So now if we see for this 9 in two operations, what we can do? Either we can split it to 1 and 8, right? So in this particular case, the maximum will be 8, right? Another possible way is that we can divide it into 2 or 7. Now here we have minimized a little more, right? And since if you see the number of operations are also given to us as 2. So this 8 can be further divided into 4 and 4, right? So in this particular case, the smallest value is 4, right? This cannot be divided further, right? And if you will divide it into, let's say, 3 and then 5, then again the maximum value would be 5, which is more than 4, right? So let's not check further. So we come here in 2 and 7. This 7 then can further be divided into, let's suppose, 3 and 4. So in this particular case, again, the maximum value is 4. Another possible case is that we can divide 9 into 6 and 3, right? Then this 6 can be further divided into 3 and 3. In this particular case, the smallest value is 3, right? So 3 is the minimum possible penalty that we can get after applying two operations on these many bags, right? So this we need to find out, right? So now how are we going to solve this? There are few observations to notice over here, that in all the bags, in the worst case, what would be the maximum balls that would be present in any bag? So let's suppose the bags are like this: 2, 4, 8, 2, right? These bags you will divide using your operations, right? But in the worst case, what would be the maximum number of balls that would be present in a bag? That would be equal to the maximum number of balls which are present in the bag initially, which is 8, right? So if let us suppose that the operations that are given to us as 1, right? And my array is 8 comma 8, right? In that case, what you would do? You can only split one of these bags because the number of operations that are given to us is 1. So you will say that, okay, I will divide this 8 into 4 and 4. Still, your maximum is going to be 8. In this particular case, your answer is going to be 8, right? So then that means in the worst case, the minimum possible penalty will be equal to the maximum number of balls which are present in our bag initially, right? And now if I ask you that what will be the minimum possible penalty in a happy case or in the best case, it would be 1, right? So if 9 is given to us here and number of operations are, let's suppose, 10, right? So even before you use 10 number of operations, you would be able to split this bag of 9 into 9 bags which are all having the number of balls as 1, right? So then that means one of the observation that we did is that whatever is our answer, which is the minimum possible penalty, that range is going to be 1 to the maximum number which is present in our array nums. Our answer is going to lie within this particular range, right? So if we see for the example, the number is given to us as 9. What is the maximum number present in the nums? It is 9 only, right? Then that means our answer can either be 1, 2, 3, 4, 5, 6, 7, 8, or 9. These can be our answer, right? Now, if I am saying that 9 can be my answer, so what does that mean? That the maximum number of balls present in any of the bag should be 9, right? Or I can say that the number of balls in all the bags should be less than equals to 9, right? If I am saying that my minimum possible penalty is 5, then that means in all the bags the number of balls should be less than equals to 5, right? So let's check for all these numbers. Let's do a linear search and check. So see, if we check for this particular one, if we try to divide this bag into some number of bags such that each bag is having number of balls less than equals to 1. So is this possible within 2 operations? No, we would require more operations, right? So then that means for 1 it is not possible. Then if we check for 2, then for 2, what we can do is that, so first we can divide it into 2 and 7, then this 2 we can divide into 2 and 5, then this into 2 and 3, and then this into 2 and 1, and something like that. So basically for 2 also, it would exceed the number of operations, right? So for this also, our answer is not possible. Then check for 3. Can we divide this into some number of bags such that each bag is having the ball less than equals to 3 within these operations? So if I divide it into 3 and 6, and then this 6 I divide into 3 and 3, so the number of operations that we have taken are 2. So then that means for 3, it is possible, right? So for 3, it is possible. Then if we check for 4, so what we can do is that we can divide this into 5 and 4, and then here we can divide it into 2 and 3, right? So the max balls are 4. So this is also possible. So we will mark it. Now, if we check for 5, so we can divide this into 4 and 5, and this 4 can be further divided into, let's suppose, 2 and 2. So again, maximum is 5. So this is also possible. So you will check that for all of these, it will be possible, right? See, for 9, don't divide it. Don't use any operations. So it will be possible. For 8, you can divide it into 1 and 8. So that is possible. For 7, you can do 2 and 7, right? So for all of these, the answer will be possible, right? We want to return the minimum possible penalty, right? And we are seeing that for all these numbers, we are able to divide our bags, right? Or split our bags. So out of these, whichever is the minimum, that is going to be our answer, right? So here 3 is the minimum. So this is going to be our answer, right? So now if you see here, 2 was a point where we were not able to divide our bag, right? Or we were not able to split our bags. And then there was a point 3 where we were able to divide our bag, right? Now, for this 2, all the elements which will be smaller than this, for them, we would not be able to split our bags with these many number of operations, right? And for all the numbers which are greater than this 3, for all of them, we will be able to split our bags with these many operations, right? So I just need to identify this particular point, right? So what we can do is that since we know the range that it is going to be 1 to the maximum number present in nums. So can we apply binary search over this particular range? If we will apply binary search, then what we will do? We will take a pointer left, which will be 1 because our range starts from 1, and we will take a pointer r, which will be the maximum number in num, which in this case is 9, right? So you will apply a binary search. You will take the mid. Now this mid, what you will check? You will check whether with this mid, are we able to split our bags with these many operations or not, right? Now how you are going to check that, let's not focus on that, that we'll discuss later. But right now assume that you are able to check that, okay, with this particular mid, am I able to split the bags with these many operations? So if it is possible, then what are you going to do? Are you going to shift your left or are you going to shift your right? So I'm saying if it is possible with mid, then what are you going to shift? So see, when let's suppose my mid was 6, and for this it is possible to split the bags. So I would go to the more smaller number because I want to minimize my penalty, right? So I want to move towards the smaller range, and smaller range is towards the left. So then that means I will shift my right, right? So my right will become mid, right? Now why we are not doing mid minus 1 here? Because for this mid it is possible to split the bags. So I want this mid to be in my next range. I do not want to exclude it because it is one of the possible penalty, right? Otherwise, if it is not possible, let's suppose for this particular case, then we have to move towards the bigger numbers which are present towards the right. So we will shift our left. So our left will shift to mid plus 1. Now why here we are doing mid plus 1? Because for this particular mid, it is not possible to split, and if it is not possible to split, then I do not want it to be considered in the next range. That is why I am doing mid plus 1 over here, right? So this thing you can do. And what is going to be a loop? It will be while left is less than r. Why we have taken less than r and not less than equals to r? Because here we are doing r equals to mid. If I will take an equals to over here and my L and r both are equal and the answer is also possible for this, then my loop will be stuck here, right? That is why we will take less than r over here, right? And once the loop is finished, our answer will be present in L, right? Because we are wanting the minimum possible penalty. So at the end, we can return left, right? So this is how we are going to identify our answer. Now the only point left here is to identify whether for this mid is it possible to split the bags or not. So that how are we going to do? So let's remove this. So let us suppose that my mid right now is 4, right? Let's suppose I am checking for this particular 4, right? So I will check in my nums array for all the elements that how many operations each of the bag is taking to be splitted into some number of bags such that each bag contains the number of balls less than equals to 4, right? So we are identifying operations for all the bags, and then we can sum up those operations and we can compare them with the max operations. So if those total operations are coming greater than the max operations, then that means it is not possible, right? Otherwise, if they are less than or equals to this max operations, then that means for this mid it is possible, right? So how to identify that how many operations is it going to take? So see, I am having a bag which is having the number of balls as 9. I want to split it into some number of bags such that each bag contains the number of balls less than equals to 4, right? So see, the operations that are given to me, I want to utilize as less number of operations as possible for a particular bag in my nums. So what I'm saying is that let us suppose that the array was 8 and 8, right? And the number of operations given to you were 2, right? If you would have applied both two operations on a single bag only, so let's suppose you would have splitted this into 4 and 4 and then this into 2 and 2. So see, although you applied operations on this bag, but still the minimum possible penalty right now in this is 8, right? This is the maximum ball present in any bag. So we could reduce this. This is not our ideal answer. We could have applied the second operation on the second bag. So this would also split into 4 and 4, right? So in this case, see, from 8 we have reduced it to 4, right? So then that means each of the bag should utilize as less number of operations as possible, and it should be able to split it into some number of bags such that each bag has balls less than equals to mid, right? So for that, what we will do is we will divide this 9. When we are checking for this 4, we will divide this 9 into bags containing the number of balls as 4, right? So we will divide this into a bag containing number of balls as 4, another bag containing the number of balls as 4, and now we are left with one ball. So there will be another bag with the number of balls as 1. So 9 can be splitted into such combination, right? So here the number of bags are 3, right? So how can you identify that for this 9 to be divided with this mid? How are you going to identify the number of bags? So this can be identified by doing 9 by 4. So 9 by 4 will give you 2 point something, right? So this 2. This 2 denotes these two bags, but in this particular case, since we were left with one extra ball, there was one more bag created, right? So instead of 9 by 4, we will be taking a seal of 9 by 4. So with this, it will give you the number of bags as 3. Then that means for splitting this bag using this mid, we will be splitting it into 3 bags, right? Now for splitting this 9 into 3 bags, how many number of operations were required? So see, initially there was one bag. With one operation, it was divided into two bags, right? Then with one more operation, it was divided into three bags. Then in one more operation, it was divided into four bags. So basically, in one operation, I got two bags. In two operations, I got three bags. In three operations, I got four bags, and so on, right? So then that means if I have got three bags, then that means the number of operations that it would have used would be 2. So we will take a minus 1 of the number of bags that we have got, right? So this will give us the number of operations required for this particular bag to be splitted, right? So these operations we can identify for all the numbers in the nums. We can do their sum and then we can compare it with the max operations, right? So what is our formula? Our formula is C log whatever is the current number, that is the ith element in nums. So let's denote it with num, divided by whatever is the mid that you are considering minus 1, right? So this will give you the number of operations required for this particular num, right? You can identify for all nums, do their sum, compare it with max operations. If it is greater, then that means for this mid it is not possible, and if it is less than equals to this, then that means it is possible, right? So let's quickly look at the code. So first of all, let's create our left and right pointer. So L will be 1 initially, and right we can keep anything. We will update it with the maximum value. So for int num in nums, in R we will do a max of R comma num. Right now we will apply our binary search that while left is less than R, calculate the mid. So mid will be equals to L plus R divided by 2. Then we need to check that if it is possible for this mid. If possible for this mid, then what you do? Move towards the left range. R will become equals to mid, right? Otherwise, L will become equals to mid plus 1. And at the end, we can return L over here, right? Now, for checking whether it is possible or not, what all things do we need to pass? First, we need to pass our mid, right? Then we need to pass our nums array, and then we need to pass the maximum number of operations that are given to us, right? So let's define this function. So this will return us a boolean and the name is possible. So first it is receiving the max number of balls that a particular bag can contain. Then we are receiving a vector which is our nums. Then we are receiving the max number of operations, right? Now inside this, we need to find out that for this max balls, how many total operations this nums is taking. So let's create a variable total operations which will initially be 0. We will run a for loop in nums. So for int num in nums, so what will be the operations that it will take? C of num divided by max balls, and since we are doing division over here and both the elements are integer, so we will make it double, right? And then max balls, and then we'll do a minus 1, right? So whatever is the operations that you have got, we will add it inside the total operations, right? And then we'll check that if this total operations is at any point exceeding the max number of operations, then we will return a false here itself, right? Otherwise, at the end, we can return a true. So now here, if you see, we are applying a binary search and our range is 1 to the maximum element which is present in the nums, right? If we are denoting the maximum element with m, so this particular loop is taking log m time, right? And inside this, we are checking is possible. Inside is possible, we are iterating inside the nums array, right? Every time. So this is taking the time as n, right? So the overall time complexity of our code is order of n log m, right? Where m is the maximum element in the array and n is the number of elements in the array, right? So let's run this code now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.